Imagine your application cache is full. A new element comes in and you have to evict something. What would that be? Is it the oldest element which you have added? Is it the least recently used one? Or something random? We are going to learn LRU, which is very important topic in the interviews. This is beyond basics. This is beyond the LRU questions. Once you explain the LRU, once you explain Redis, the cache eviction policies, these are the questions would come to you, and this is why this video exists. So stay tuned with me. I am Gaurav and you're watching Underflow with Gigi. What does LRU means? It means least recently used. Now we are going to understand it from two different perspective. One is a single machine, how it works, and also on a distributed system. Okay, if your L1 cache takes 1 nanosecond, it is humanly impossible to experience the 1 nanosecond. So I have kept it similarly 1 second, just to understand on a human scale. So for imagine you have a element which your system gives back from L1 cache in 1 second. The same element from the L2 cache would take 4 seconds. The similar element would take 2 minutes. The similar element on a SSD would take 28 hours, 6 days, and 4 months from a HDD seek. Okay. L1 cache is something which lives on your CPU chip, very small memory for the instruction purpose only. L2 is also the same, but slightly larger memory. Then comes RAM. RAM is, of course, where your entire cache data sits and you get it very fast. Now the question, where your application cache is full, what do you throw away? Now there are techniques. Techniques are FIFO, first in, first out. So throw out the oldest one regardless of use. LRU, least recently used, which we are going to understand. LFU, least frequently used. Throw out what's been touched fewest times. Random. You would laugh, but I'll tell you this is a very effective technique to pull out the random elements and evict it. Then comes the TTL, throw out whatever expires first, okay? Now meet LRU. If you haven't used it in a while, you probably won't use it again, okay? The analogy is your desk has space for the 10 books and you got 11th book, something you have to put back on your shelf. Which one would you do? Which one would you keep on the shelf back? Of course, the one which you haven't used in recent while, and then you cannot put back the book which you were reading yesterday. Okay, so yeah, based on that analogy, think how the elements eviction also works. Okay, now this is a very brute force technique, naive LRU, just the timestamp everything. There is a struct which has value in last access time. Now you want to put it a new element. While putting a new element, what you would do, you would just run a for loop and scan every key. Okay, every key and which one is the oldest one, and you would remove it. You will just compare it with the current time and you would just remove that one. Okay, it works, but it is terrible. Do not use it in your production system. Now, there are two data structures working together to implement actual LRU. First one is HashMap and second one is doubly linked list. What HashMap keeps? To understand, so HashMap keeps key of each node and a pointer to that node. Okay, so A is a key and as a value it will keep a pointer to that node. So suppose I want an element from the linked list which is C. I will directly go to the hash map. I will ask, do you have a C? If yes, what is the address of the C? And it will point me to C directly. This is O1 lookup. This is not a linear, this is very fast direct lookup. Okay, that's what makes it very fast. Now suppose this is the initial step. A is your most recently used and F is your least recently used. Now you would say get C here. Okay, now when you say that, what will happen? HashMap finds the node in O1. As I explained, it will the map will dereference. Key C gives us a direct pointer to linked list node. No scanning, directly it will give. Now I have to delink C from here. In order to delink, I have to delink the next pointer, previous pointer. Okay. C would move to front. So unlink C from the middle, splice at front because it's a doubly linked list. Okay. Your B has to be connected to the D. You also have to update that B's next now is D and A's previous is now C. These are the three operations you have to do. I hope you are understanding. The first operation would be you have to delink the C. You have to say C. Now your next pointer is A. A, your previous pointer is C. B, this is a first. Then B, your next is D. And D, your previous is B. Now a new element comes in like G. You have to accommodate G, but you have to remove something. As a cache eviction policy, you would remove the F. Similarly, like this, you would delete the F. G is incoming. So now G's next is A. A's previous is G. And this is how it will look. This is a tail. This is a head. Okay. Now every operation in constant time, get, put, and evict everything. Okay. Now a lot of developers do this mistake, and I think in interview also sometimes when a follow-up question comes, what kind of locking you would use? A lot of developer would think to save the resources, they think, okay, we will put only read lock, which is wrong. In LRU, get is not only the read operation, it is also a write operation, because remember, you are getting an element and you are updating the list also. So when you're updating the list also, it automatically gives you read and write lock contention together. You cannot keep only read, you cannot keep only write. So if you are keeping only read, the move to front is not thread safe anymore. So you have to keep a full lock over here. Okay. Now sharded locks. You need not to keep one hash map and keep on updating it. Instead, what you can do is for a parallel processing, you can keep multiple hash map. For example, 16 hash map you can keep, and you can put the data in the hash map using your own algorithms. Basically, you can use the sharding methods to put the data, and you can put multiple locks which will give you a very parallel feel. When you are evicting something, you are getting something, pushing to front, you are evicting something, everything will give you a very parallel system there, rather than keeping just one big lock on a one big hash map. Okay. Now there is a myth that Redis uses LRU, which is Redis does not use LRU. So basically, there are multiple cache eviction policies. What Redis does instead, this is one of the way. Per object 24-bit access timestamp. When evicting, it sample n random keys. Suppose you have 100 keys, it will just sample 10 random keys. From those 10 random keys, it will evict the oldest one, drop whichever has the oldest timestamp. Okay. So with this way, you need not to keep a global list. There is no lock contention, nothing. You just have to pick 10 random keys and just remove it. Okay. 1, 2, 3, 4, 5. And you can just, if you have 20 keys, you can select 5 and remove the oldest one. This works very well. Okay. Not a globally oldest key, but the cold key, and that's good enough. at N10, Redis sampling is nearly indistinguishable from true LRU. Okay, you have to take that as a data. Now, these are the some of the eviction policies. No eviction is well understood. Volatile LRU is approximate LRU, but only with a only keys with a TTL. What does it mean? Generally, in Redis, we do not keep keys only with the TTL. We also keep some of the keys in Redis to access faster, like a config keys or something, uh, front-end configuration, some different kind of configuration where it does not have a TTL at all. So volatile LRU will not touch those keys which does not have TTL. Similarly, volatile LFU, least frequently used. Volatile random, which we just discussed, that it will pick random keys and delete. All keys LRU. This includes the keys which does not have TTL. All keys LFU, similar. All keys random, same, but without and with TTL. And volatile TTL, evict whichever expires soonest. Suppose some key which is any which way is going to expire in next 5 minutes. It does not matter if it expires 5 minutes before, and that is how it evict the element. Random eviction is shockingly close, 95% time, as good as LRU on many workloads with zero bookkeeping. Now, things to remember. LRU is equal to HashMap plus doubly linked list. Both gives O1. It's not a linear time, it's a direct O1. Get is a write operation also. It's not only the read operation. Just remember that. Sharded locks for parallelism at the cost of the local LRU. Distributed caches use consistent hashing. Each shard runs its own LRU, which we discussed. If you have 16 different hash maps, you can keep the consistent hashing to put the data inside the hash map. Okay. Um, Redis fakes LRU by sampling. It actually does not fake, but there are multiple cache eviction policy. It looks like it is doing a LRU, but there are multiple cache eviction policies and you can choose. I hope I'm able to explain the LRU and the questions which would come as a follow-up questions in interview. I'm going to make many such videos which won't be only on the interview questions, but on the follow-up questions. So stay tuned with me. Subscribe to my channel, Underflow with Gigi. Thank you.